Alright, so for this rational function, which you see right here, x minus 1 over x squared minus 2x minus 8. Now it seems simpler than the last video, the last example. So let's get down to graphing. Now before we can actually do some graphing, we need vital information like the asymptotes, the intercepts, coordinate points. So let's take a look. If you look at the original function right here, we notice that the exponent of the numerator, the leading exponent in the numerator, is less than the leading exponent in the denominator. So if we go back to this, so the numerator, the top degree, was less than the denominator, the bottom degree. So our horizontal asymptote is y equals 0. So if I write it out, top degree is less than bottom degree, then our horizontal asymptote is y equal 0. So here's one important information we need. Now our second one, what we can do from here, now this is the factor function. Again, these are the factors for this denominator. So x plus 2 and x minus 4, since it's already factored, and we see that there's no common factors, so that means that we have two vertical asymptotes. So we're going to solve for each factor. So x plus 2 and x minus 4 equal to 0. So this one, x equals negative 2. And then here, alright, so here's our two vertical asymptote. First one is x equals negative 2 and x equals positive 4. So we got our asymptotes. Alright. And next, what else we can find is the intercepts. So I prefer to look at the factor functions when everything is factored, to look at the intercepts. Now, just like in the last video, if we were to do x-intercepts, all we do is just look at the factor in the numerator. Now if you're looking for the y-intercept, then you just set all x's equal to 0. So let's do the x-intercept. And it's pretty much the same as vertical asymptote. So we only send a numerator. Basically it's x minus 1 equal y, and then we're just changing or plugging in y with 0. So solve for it just like vertical asymptote. So x equal 1. So remember, the intercepts are always coordinates. So x-intercept is 1, 0. Because again, 0 was the number that I plugged into y. Now the other one that we can find is the Y-intercept. So just like before, I plugged 0 into Y for X-intercept, I'm going to plug 0 into X for the Y-intercept. So plugging all the zeros into X's. Now you could do it for the factors or for the original function. It will come out the same. So let's say we do the original since this is foiled. So I'm going to put 0 minus 1 on the top. And then the first one is x squared, so it's going to be 0 squared and then it's minus 2x, so that means minus 2 times 0 and then minus 8. Alright. So 0 minus 1, this was x squared, so it's now 0 squared. This was minus 2x, so now it's minus 2 times 0 and then minus 8. So working on the top, 0 minus 1 is negative 1. And then 0 squared is just 0. Minus 2 times 0 is just minus 0. And then minus 8. That would become negative 1 over negative 8, which therefore becomes positive 1 over 8. Alright. So what we can do is now convert it into a decimal. So simple long division with numbers. So 8 dividing 1. So here's 8 dividing 1. So 8 does not go into 1. So what we do is put a 0, then a decimal. After I do that, then I can add a 0. Now 8 can go into 10 one time. So now I'm left with 10 minus 8, 2. So if I add another 0, that's 20. And then 8 goes into 20 2 times, which is 16. Remainder of 4. Now, I'm going to stop here because I don't need to go any further. Now, if you want to be precise, you use 0.12. But for graphing, I'm going to use 0.1. 0.1. So, our Y-intercept is going to be, again, it's a coordinate point. So, 0.1 comma, actually no, because I plugged in 0 for x and the y value is 0.1. So that's our y-intercept right here, 0, 0.1, and our x-intercept is 1, 0. Alright, now let's take a look at the asymptote, the vertical asymptote. We know that 0 and 1 is between negative 2 and 4. So what we need is a few additional points. One or two less than negative 2 and 1 or 2 greater than 4. So now if I make our chart, again, I'm using the vertical asymptotes. So our x, y table, alright, so I don't know how many points we're going to make, but let's see. So for -2, to be safe, let's get two values less than -2. So -4, -3. We don't have to write -2 because it's an asymptote. Now we need numbers between -2 and 4. We got 0 and we got 1. So let's do -1. And then I'm going to write 0 because we already got 1. And then 1. Alright, now we need to be precise. Two x values that is greater than 4. So we're going to do 5 and 6. Alright. Now, again, we got the x-intercepts. So 1, which is right here, I'm going to put 0 because that's what we have for the y value. Now for the x value, 0, we have 0.1 for the y value. So I'm going to put 0.1. Alright. So now all we do is just plug in these values into the function right here and get the y value. Alright. So let's start with -4. So what we're going to do is we're going to plug -4 into all the x's here. So -4 minus 1 over -4, remember, parenthesis, square, minus 2 times -4 minus 8. Alright, so if we do the top, -4 minus 1 is just going to be -5. Alrighty, -4 square, so that means -4 times -4, so 16. Then minus 2 times -4, that's just plus 8. And then minus 8. So it's -5 over 16 plus 8 is 24, and then 24 minus 8 is just 16. Alright, so we got -5 over 16. So to convert this into decimals, we're going to do division. So and it's negative, so we know that the answer is going to be negative, so we just convert it into decimal. So 16 dividing 5. Alright, we know 16 can't go into 5, so we're going to put a 0 and then a decimal, and then after that I'll put a 0 next to the 5, making it 50. Now 16 does go into 50, so I would say 3 times. So 3 times 6 is 8. Carry the 1, so 3 times 1 is 3 plus 1, 48. So the remainder is 2. And add a 0, bring it down, 20. 16 going to 20 one time. Oops. So if I want to be precise, I would use 0.31, but for graphing wise, we're going to use 0.3. Now, again, since that was negative, this will be negative. Alright, so we plug in -4, so our y value will be negative 0.3. Alright, next is -3. So we're going to plug in -3 into all the x's again. -3 minus 1. Alright, negative 3 square minus 2 times negative 3, and then minus 8. Alright, so at the top, negative 3 minus 1, that's going to be negative 4. Negative 3 squared, so negative 3 times negative 3 is a positive 9. And then negative 2 or minus 2 times negative 3 will be a positive 6. And then minus 8. Alright. So if we look at this one, 9 plus 6 is 15. And then minus 8 is 7. So we're left with negative 4 over 7. Negative 4 over 7. Now to convert that to decimal, same thing as we did right here. So 7 goes on the outside, 4 goes in the inside. And remember, since that's negative, your answer will be also negative. 7 does not go into 4, so I'm going to put a 0 and then a decimal, and then I'll add a 0 next to the 4, making it 40. So 7 will go into 40 5 times. 5 times 7 is 35. And I'm left with a remainder of 5. Now, again, I can go further to make it precise, but we're just going to use one decimal value for graphing. Now again, since that was negative, this will be negative, so 0.5. Now it does look like it's 1/2, but if I were to go a step further, 50. Now then I would use 7, which is 49, remainder 1. Now it's not exactly half anymore, it's 0.57. But for graphing wise, we're just going to use negative 0.5. So here, negative 0.5. Alright, now next we're going to do negative 1. So we're going to plug in negative 1 into all the x's. So negative 1 here, and then minus 1 over negative 1 squared, remember the parentheses, minus 2 times negative 1 minus 8. Alright, so at the top, minus or negative 1 minus 1, negative 2. Negative 1 squared, negative 1 times negative 1 is just 1. Minus 2 times negative 1 is just plus 2, and then minus 8. Alright, so we know that at the top, the numerator will be negative 2. 1 plus 2 is 3. 3 minus 8 is negative 5. So negative 2 divided by negative 5 is just 2/5. And then if we were to divide again, 5 goes on the outside, 2 goes on the inside. 5 doesn't go into 2, so 0, and then decimal, and then I add a 0 next to the 2. Now that's a 20, so 5 does go into 20 4 times. Remainder 0. So 0.4. Now it's positive, so that's positive. So 2/5 is 0.4. So I'm going to write here 0.4. 0.4. Alright, next we're going to do 5. So just plug in 5 into all the x's, so 5 minus 1. So 5 squared minus 2 times 5 minus 8. Alright. So 5 squared is just, well, hold on, the top. 5 minus 1, that's just 4 in the numerator. Alright, 5 squared is just 25. Now, minus 2 times 5, again, minus 2, so that's going to be minus 10, and then minus 8. Alright, so we have 4 on the top, 25 minus 10, that's 15, and then 15 minus 8 is just 7. Now, we just did this earlier. We had a negative 4 over 7. So, and it's positive, it's going to be the same number but opposite sign. So earlier we did the long division and we got 0.57. But for graphing wise, we're going to use 0.5. So here, for 5, we're going to use 0.5. Alright, next and last, we're going to do 6. So 6, going to all the x's. So 6 squared minus 2 times 6 minus 8. Alright, so 6 minus 1 is 5 on the top. 6 squared is 36. Minus 2 times 6 is minus 12, and then minus 8. Now if we were to look at it from left to right, 36 minus 12, well that's 24. 24 minus 8 is going to be 16. So we just had this one earlier, but it was a negative version. So again, it was a negative version, so we did 0.31. That was earlier, and it was the negative versions of it. So earlier we had negative 5 over 16, which was negative 0.31. So we don't have to do long division since we already did that. It's just opposite sign. Now graphing wise, we're just going to use 0.3. So here for 6, 0.3. Now if you want to check, you can always use long division. Now let's get down to graphing. Now we're going to use all this information here. Now, as I said in the last video, when it comes to asymptotes, the graph doesn't usually cross it, it goes near it. Now there's going to be a special case like this one where it will cross the horizontal asymptote. Even though it has the word asymptote, about 99% of the time it won't cross, and I will explain about the vertical asymptotes. Alright, so now we're going to use this as a center, 0, 0. So I'm going to mark it as the center here. So this is our x-axis, and here is the y-axis. So we got the vertical asymptote at -2 and at 4. So let's zoom in a bit. So again, we had one vertical asymptote at -2. So -1, -2. So I'm going to mark that as our vertical asymptote. And then we had another one at 4. So 1, 2, 3, 4. So right here. Alright. Aside from that, we also have a horizontal asymptote. our horizontal asymptote is y equals 0. So at y equals 0 is right here, horizontal asymptote. Alright. Now let's label the points. Alright. First is -4 and -0.3. So that means that I'm going to zoom in a bit. Again, this black dot, let me make it a bit bigger. And let me use a different color. Alright, so at -4 and -0.3. So, -1, -2, -3, -4 at -0.3. So that means it's less than the half towards -1. So here's half, a -0.5, and I just need a graph at 0.3. So it's going to be a bit above halfway, right there. So that's -4, comma, -0.3. Alright, now -3, -0.5. So this was -4, so this one right here is -3. Or I could start from here, -1, -2, -3. And I'm at, for the y value, -0.5. So that means I'm halfway towards -1. So if you look at this, you see how if I were to go from left to right, it's decreasing, so I'm going to go downward. Now, our next one is -1, positive 0.4. So right here is -1, and then I'm going to add 0.4. So it's less than halfway towards 1. So here's 0 and here's 1 for the y value. So again, it's 0.4. So at -1 as my x, my y value is 0.4. So I'm going to be a bit below halfway. So -1, comma 0.4. Now at 0, I'm at 0.1. So here's 0 for the x, and then for 0.1, it's going to be just below that big black dot for the origin. So I'm just going to mark it right here. Now next is 1, 0. So 1, 0, that's simple. Here's x as 1 and here's y as 0. So right here. Well, actually I made a mistake. For this one, I said 0.1, but I marked at -0.1. So 0.1 is actually above. It's positive. So it's less than the one over here. It's greater than the one over here. So for our y-intercept 0, comma 0.1, 0.1, the y value is right there. Alright. Now next is we're going to do 5 and 6. So 5, comma 0.5. So 1, 2, 3, 4, 5. At 5, I'm at 0.5. So that means I'm going to be up here, halfway between 0 and 1. So again, this is my origin, 0, 0, 1, 2, 3, 4, 5. And then the y value is 0.5, so I'm going to be up halfway between 1 and 0. Now 6 is right here, and then it's 0.3. That means, I'm going to zoom in a bit for you. So again, this is 0.5, so therefore, this will be below for 0.3. Alright. Now if we were to graph, So let's start with the right side. So you see how this is less than 0.5. So you connect it, it's going to curve. So again, this is the horizontal asymptote. So that means the graph won't cross the horizontal asymptote, nor it won't cross the vertical asymptote. But as the graph goes further upwards, it will be closer to the vertical asymptote. As the graph goes further right, it will be closer to the horizontal asymptote. So let's graph that. So that's what the graph would look like. So again, if I zoom out, that's what the graph is going to look like. And again, as it further going upward, it's going to be closer to the asymptote but never cross. Same thing with the horizontal asymptote. Now, let's focus in the center. So here it's connected from 0.5 or 0.4 to 0.1 to 0. So if I were to graph that, I'm going to connect starting from here, going to those 3 points, and it's going to be like this. And then here, it's going to go upward, closer to the vertical asymptote. Now, even though this is the horizontal asymptote, this is a special case where the graph in the center, it goes through it. So it can go through the horizontal asymptote, but it won't go through the vertical asymptote. So if I zoom out, you see that it is going towards near the vertical asymptote, but it doesn't cross. Now let's talk about the one over here. So you see how this point right here is less than that. So if I were to connect it, it's going to look like this. So I'm going to graph it, and then this one's going down. Again, it's going towards the vertical asymptote but not cross it. Same thing with the horizontal asymptote. So here's our graph. This is the left side. Again, this one won't cross the horizontal asymptote, neither won't cross the vertical. Same thing on the right side. It won't cross the horizontal asymptote, nor cross the vertical asymptote. But in the middle, it crosses the horizontal asymptote, but not the vertical asymptote. So this is the graph for the function x minus 1 over x squared minus 2x minus 8. Now if you graph this in decimals, you will see a similar graph just like this.